In this video, we'll take a look at what a definition of a quadratic equation is, and then we'll see how we solve quadratics by a method of factoring. So what is a quadratic equation? So we've solved linear equations. A general quadratic is in the form ax squared plus bx plus c. Notice there's an x squared term this time. So our solution is going to be, method is going to be a little bit different than when we solve linear equations. So just some practice on what is a quadratic, what isn't. Examples that are quadratic equations are equations that can be written in this form, ax squared, where a is a number or an expression of some sort, plus b times x plus c equal to 0. So a, b, and c are numbers or values, and a can't equal 0, because if it did, we wouldn't have an x squared term anymore. So examples that are quadratic, the first one, x squared minus 4x minus 5 is quadratic. A would be 1, b would be negative 4, and c would be negative 5. The next is also a quadratic equation, 3x squared minus 6. Even though it doesn't have a middle term, that could be written as 3x squared plus 0x minus 6 equals 0. So a is 3, b is 0 in this case, and c is negative 6. So what matters is that a isn't 0. B can be 0, and so can c. Next equation is quadratic. If you took the 7x to the other side, you'd get 2x squared minus 7x equals 0. A is 2, b is negative 7, and in this case, c is 0. Next, we still have a quadratic. If we were to solve or rewrite this equation with everything on one side, 0 on the other, we could subtract x squared from both sides, and we would end up with 3x squared minus 2x is equal to 0. So that's similar in form to the one above. And the last, the x plus 1 squared is equal to 4. If we were to multiply that out, we would end up taking x plus 1 times x plus 1, which is x squared plus 2x plus 1 equal to 4. We can subtract the 4 from each side, and we end up with a quadratic as long as it's in this form. Examples that are not quadratics, 2x minus 6 equals 0 is linear. There is no x squared term. Next, we have x cubed minus x squared minus 5 equals 0. That's not a quadratic because it has an x cubed term. It's not in the form x squared x. Last, this starts out looking pretty good. X squared plus x plus 7 equals x squared. But if we were to get everything on one side, the x squareds would cancel out, and we'd be left with x plus 7 equals 0. So that's not quadratic anymore. So once you recognize that you do have a quadratic, there are a couple of different methods that we use to solve. The first one is by factoring. And factoring only works if your equation is factorable and if you're pretty good at factoring. So we're going to take a look at, first of all, to how to solve a quadratic equation by factoring. And then we'll take a look at what kinds of solutions can I get. So the procedure is to collect all terms on the left and simplify to that quadratic form, ax squared plus bx plus c equals 0. Then factor the quadratic expression. So on this, we have x squared minus x minus 12 equals 0. We're going to factor the left-hand side. X goes in the first spot, and then we want two numbers so that when we multiply them together, it equals negative 12. And when we add them together, it equals the middle term, negative 1. The two numbers that satisfy that are 3 times negative 4 and then 3 plus negative 4. So this would be plus 3 minus 4. So now we factored our quadratic and we have the expression equal to 0. At this place, we're going to use something called the zero product property. We're going to take each term, each x plus 3 equals 0, or each factor, and set it equal to 0. Why is this okay? Because if you have two numbers multiplied that equal 0, then either A has to equal 0 or B has to equal 0. One or the other has to be 0. So that's what allows us, it's called the zero product property. That's what allows us to set each factor equal to 0. But it has to be a 0 on the right-hand side. It can't be any number. So then we solve each linear equation. We end up with x equals -3 and x equals 4. So this quadratic has two solutions, -3 and 4. That means both of these will be solutions to this equation up on the top. So in general, a quadratic, if you have an x squared term as your highest power, can have as many as two solutions. So let's try a couple more examples of factoring. Next example, we're solving x squared plus 4 is equal to 4x. It's not in the right format. I have to have everything on one side equal to 0. So I'm going to subtract 4x from both sides, and I want to make sure to put it in the middle to get it in the right format. Then we want to factor. This has three terms. So you can either recognize, you can go the process we did above, x, x. We want two numbers so that when we multiply them we get 4, and when we add we get -4. The choice for that is -2, -2. Or you could notice that this is a perfect square. The perfect square is x minus 2 squared equals 0. Okay? Either way, we have two factors. They happen to be the same, set equal to 0. So when we set each factor equal to 0, we end up with x equals 2. We end up with the same solution twice. So the solution is actually just x is equal to 2. So we can end up with one answer where you end up with the same answer twice. So that's another thing that can happen with solving quadratics. Okay? So far we've had two solutions, one solution, or the same solution twice. Next example, we're going to solve 3x squared minus 6 is equal to 0. All right, well we can factor. We can factor a 3. We're left with x squared minus 2 equal to 0. And then set each factor equal to 0. This x squared minus 2 doesn't factor. So I'm going to say 3 equals 0 or x squared minus 2 equals 0. That's a false statement, so I'm just going to cross it out. Now, there's a square root property, so even though we factored out the 3, we can't factor x squared minus 2. But what we can do is we can isolate the x squared term by adding 2 to both sides. And then there's a property called the square root property that says if you have x squared equal to a number, then x is equal to, take the square root of both sides, x is equal to the positive and the negative of that square root of that number. So we get two answers here. X equals the square root of 2 and x equals negative square root of 2. So even though we don't know what these are exactly, you can put them in the calculator to get an estimate. These are the two exact solutions that will work in this particular equation. I just wanted to show you that example, as if you're missing the middle term, you can solve this by isolating x squared and then square rooting both sides. Okay? So the next part, now that we've factored a few, is how many solutions are possible. So we've got a couple of examples, 3 examples that we're going to look at. We're going to factor and see what the nature of the solutions looks like. So we're going to try, let's factor 3x squared minus 7x plus 2. We know that 3x and x go in the first spot. This is the factoring where we're doing trial and error, basically. So I know that 3x times x is the only combination to get 3x squared. Now I need two numbers multiplied that give me 2. I'm either going to get 1 times 2 or 2 times 1. And I try to find the combination that's going to give me a minus 7 in the middle. Okay. So the only way, 2 times 3 is 6. The only way to get a largest number as 7 is to make a 2 here and a 1. The middle term is negative. The 2 is positive. So both of these will have to be negative. And if you're not quite sure, multiply it out to make sure that it equals this. So we're okay. Once you figure out how it factors, take each individual factor and set them equal to 0. And then solve the two linear equations that result. We add 1 to both sides, divide by 3, x equals 1/3, and x equals 2. So the two solutions are x equals 1/3 and x equals 2. So this is a case where we got two distinct solutions. Next, we get one solution. So take a look. Notice that that is a perfect square. X squared is a perfect square. 9 is a perfect square. 3. And then the middle term is 2 times the square root of the first term times the square root of the last term. So what does that mean? The perfect square here is x. The perfect square here is 3. Is the middle term 2 times the product of those two? Answer is yes. So that factors into x plus 3 squared is equal to 0. So when we set each factor equal to 0, we're going to get the same answer twice. So x equals -3, x equals -3 again. So one solution is x equals -3. It just happens twice. Last example is what happens. There are times where you don't have a real solution. So x squared plus 4 equals 0. We can't factor. It's not a difference of squares. That's a +4 and not a -4. So I'm going to use that property from before that says I can isolate the x squared by subtracting 4 from each side. Then take the square root. X is equal to positive or negative. The square root of -4 is not a real number. It's an imaginary number. So it's actually 2i. So the square root of 4, we call it no real solution. Or if you're going to work in complex numbers, your two solutions are positive and negative 2 times I. But for us, at this time, it's no real solution. Okay? So I've got a couple of practice problems where you might have to factor more than once. You have to factor completely. So first example, we have 12x minus 42x squared is equal to 0. We want to put this in the correct format. So the x squared term should go first. So I've got -42x squared plus 12x is equal to 0. Then factor out the greatest common factor. What goes into both 42 and 12? Let's see, the answer is 6. And if you want to factor out a negative at the same time, let's take a -6 out of each. Notice we have an x squared and an x term, so they also have an x in common. So the greatest common factor is 6x. When we divide each term by 6x, -42 divided by -6 is +7. X squared divided by x is x. Plus 12 divided by a -6, so that's a minus. So we end up with minus 12 divided by 6 is 2. X divided by x cancel each other out and equal 1. So our fully factored greatest common factor is -6x times 7x minus 2. Then we still take each of those and set them equal to 0 and solve. In the first equation, divide both sides by -6. We end up with x equals 0, so that's a solution. Also, add 2 to both sides, divide by 7. X equals 0 and x equals 2/7. So even when you have a single term like -6x equal to 0, x equals 0 is still one of the solutions. All right, last example. Solve 16x cubed minus x equals 0. And you're saying, well, wait a minute, that's not a quadratic. So the first thing we do is factor out the greatest common factor and then see if what you have left is a quadratic. Notice that x goes into each one of these. So if we factor out an x, we're left with 16x squared minus 1 is equal to 0. Now the 16x squared minus 1 is a quadratic, and we can factor it. It's a difference of squares. That factors into 4x plus 1, 4x minus 1. So as we set each individual factor equal to 0, so even though our original equation was actually a cubic third degree, we can still use our factoring of quadratics to solve. So we solve, we get x is equal to negative 1/4 by subtracting 1 divided by 4, add 1 divided by 4. In this case, we ended up with 3 solutions. X is equal to 0. Let's see, type each solution once, use a comma. 0, negative 1/4, and positive 1/4. So that shows you can still use quadratic factoring to solve a quadratic, even if your original equation might have a cubic.